This video is a demonstration of ImageSim software by Volmo Private Limited. ImageSim software allows you to import CT or MRI datasets and helps you convert the image into a 3D model. Now, since we need to import an image to see the functionality of the software, first we will go to the File drop-down menu. File drop-down menu offers many functionalities such as opening files of different format including .analyze, opening an existing sequence, opening recent files, and importing files in STL, mask, RAW and GIPL formats. You can also use the file drop-down menu to load an existing project. Since we need to import a DICOM sequence, select Open Sequence and select the location of your DICOM files. Please wait while your files load. Once the dataset has been imported, the next step is to filter the image. For the most basic filtering, we will be using smoothing filters, but it also leads to the advantage of smoothing filters is that it removes noise. There are 3 smoothing filters offered in this software, but we will be using the most basic, that is recursive Gaussian advanced filter. This is mainly used when there are no strict limitations in preserving the boundary of the image, as it can sometimes lead to image blurring. The value of sigma is adjusted according to your preference. The higher the value of sigma, the higher will be the level of smoothing. Click apply and hence your image is smoothed. The next step is contrast stretching. Contrast stretching is used in order to increase the level of contrast in the entire dataset. Now there are 2 options, either piecewise linear or piecewise non-linear. I will be using the simplest, that is piecewise linear. In contrast stretching, the lower threshold is defined as such that everything below the lower threshold goes to 0 and the values between the lower threshold and the higher threshold increase linearly. Click apply. The next step is image cropping. We need to crop the image in order to localize the region of interest. Under the transformation ribbon tab, there is an option of cropping. Select that. Define your parameters of X, Y and Z in order to crop the image in the 3 views. Click apply and hence your image is cropped. The next step is image segmentation. Image segmentation is used to create a mask which is later converted into a 3D model. There are many methods of image segmentation, but for simplicity I will be using the simplest method, that is threshold segmentation. In threshold segmentation, you define a lower threshold and a higher threshold. The intensity of the pixels that lie within this threshold will form the mask, whereas the rest are excluded from the mask, as you can see through this demonstration. Since we need to localize the lung area, we will be adjusting the parameters accordingly. Click apply and hence your image has been segmented. As you can see in the video, although we have localized the lungs, the background has also been segmented. In order to remove this, we use a feature in ImageSim called extract largest object. And hence the image has been successfully segmented. There are many other methods of automatic and manual segmentation which I will be demonstrating in the later videos. Now that the image mask has been generated, the next step is to generate a 3D model of the same. Select the mask, click Generate 3D Model. And hence your model has been generated. The next step is to smooth the model to remove any aberrations. Select the model, click Model Smoothing, select Basic Smoothing, keep the parameters as default and click Apply. Now that the model has been smoothed, it is ready to be exported. For that, click Preview and click Export. Your file will be exported in STL format. This STL model can be directly volume meshed now. I will be demonstrating volume meshing in the later videos. Thank you for watching.